Students, welcome to SOURAV classes. Today we are going to solve a few questions on real analysis. The question is, which of the following are uniformly continuous on 0, 1? Option A, fx is equal to 1 by x. Option B, fx is equal to sin x by x. Option C, fx is equal to sin 1 by x. And option D, fx is equal to cos x by x. Now, since all these are continuous in the open interval 0, 1, so to check their uniform continuity, we have to check that limit x tends to 0 fx and limit x tends to 1 fx exists finitely or not. Now, for option A, limit x tends to 0 fx is equal to limit x tends to 0 1 by x tends to infinity. Thus, this is not finite and therefore not uniformly continuous. Therefore, option A is incorrect. Now, option B, fx is equal to sin x by x. So, limit x tends to 0, sin x by x is equal to 1. This is the standard result. And limit x tends to 1, sin x by x is equal to sin 1 by 1, which is finite. Now, since both are finite, so this is uniformly continuous. Therefore, option B is correct. Now, option C, fx is equal to sin 1 by x. So, limit x tends to 0, fx is equal to limit x tends to 0 sin 1 by x, which is equal to sin infinity, which is not defined. Therefore, option C is not uniformly continuous. And for option D, so limit x tends to 0, cos x by x is equal to 1 by 0, which again tends to infinity, is not finite and therefore not uniformly continuous. Therefore, option D is incorrect as well. So option B is the only correct answer. The next question is, consider power series summation n is equal to 1 to infinity z to the power n factorial. Then the radius of convergence of the series is option A 0, option B infinity, option C 1, and option D a real number greater than 1. Now we use the ratio test here, which is an is equal to z to the power n factorial. Now 1 by r is equal to limit n tends to infinity an plus 1 by an, that is limit n tends to infinity z to the power n plus 1 factorial by z to the power n factorial, which is equal to limit n tends to infinity mod of z to the power n plus 1 factorial minus n factorial, that is equal to limit n tends to infinity mod z to the power n into n factorial. Now, if n tends to infinity, then mod z to the power n into n factorial tends to infinity. If mod z greater than 1 and this converges if mod z less than 1. So the series converges for mod z less than 1, and thus the radius of convergence r is equal to 1. Therefore option C is the correct answer.